Hi there, in this lesson we're going to be looking at variance and standard deviation. And before we really get into those, we got to remind ourselves of our measures of central tendency, because these are going to come into play a little bit as we use variance and standard deviation. Really, the most important one is the mean. But our measures of central tendency are, remember, mean, median, and mode. The mean is the average. It's where we add all the data values together and then divide by how many we have. The median is the middle value in the data set, and then the mode is the one that occurs most often. And really these are used for different things. Like the mean is used when we have really evenly spread data values. The median is used if we have any outliers thrown in there, because outliers tend to throw our mean off a little bit. And then the mode can also be used if there are outliers, but really the mode is reserved for if almost all of the data values appear to be the same thing. Okay? So as we look at this, again, these should be review, but when we look at something like this, here's an example of bowlers and the scores that they got in a particular league or something like that. And we want to find the mean, median, and mode here, all right? So the mean, remember the mean, we just add all these guys together and then divide by how many we have. So I'm just going to take all of these data values right here and all of these data values right here, and I'm going to add them up. And when I add all these together, it looks like it gives me 976. And now I have to divide that by how many data values I have. Since there are 8 bowlers, that means there are 8 data values here, so I'm going to divide this whole thing by 8. And when I do that, the mean that it gives me is 122. So that's the average of these things, all right? Next, we're going to find the median. Remember, the important thing with the median, we have to write these out in order because we're looking for the middle value. So I'm going to write these in order, starting with the smallest. And even if I have values that are repeated, I write them as many times as they appear. So it looks like the 104 is the least. And it looks like I actually have 3 of those. So let me write all 3 of those out. And next up, we have the 113. And then it looks like the 117. Oh, sorry, I missed the 109 in there. Let me try again. So the 109, then the 113, then the 117. And then after that, it looks like I've got the 136, and then the 189. And just as a quick check, just count how many values you have here. It should be a total of 8 to make sure you didn't miss any, or you cross them off as you write them. So now the median, all we do is go to the center. So if I start counting in from each end, so I take 1 off of each end here, and I just start counting in from each end until I'm left with the center value. And what happens here is I can't get to an exact center value. I'm kind of caught between 2 of them. If I land on an exact center value, that's my median. If I'm caught between 2 of them like I am here, what I do is I take the average of these 2, all right? So I'm going to average out these 2, so I add them together and divide by 2. And when I do that, it gives me a 111. So the median here is 111. Okay, it's the value that falls directly in the middle. All right, and we've done other things from there, like where we found the median of each of these halves. These guys right here, remember, those are our quartiles, our first and third quartiles. And there's a lot of different values that we've found out of this, but really we're just focusing on the mean, median. And then the last thing here, the mode. If I were to go back and look at this data value, and I could look at the original, or I can look at where I have them written down in order. Sometimes it's easier to look at the ones that are in order because I can see all the data values that are same side by side. And so for this one, the value that repeats the most often is these guys right here, the 104s. There's 3 of those, so the mode on this one is the 104. Okay? And as I start to look at this data and identify mean, median, and mode, and just thinking about the uses for these, the most accurate representation of this data is probably, I would say, either the median or the mode this time. More likely, I would say the median is a good representation of this. The reason it's not the mean this time, usually we tend to go with the mean, but we've got one value that's unlike the rest of the data values here. This guy right here, bowler number 5, should not be participating with the rest of these bowlers because he's way above their average. Okay, he's much better than the rest. He's an outlier. Okay, and so the best representation of this data is probably the median because the mean is skewed by that really high value. Okay. Okay, so these are measures of central tendency. They kind of represent kind of the average or the middle placement of this thing. It kind of shows us what value these data points are revolving around. Okay. Variance and standard deviation, these measurements essentially show us how spread out our data values are. So when you think about like measures of central tendency, measures of central tendency kind of zero in on the average or the center, or what these data values are kind of revolving around. So they're kind of focusing in on the average, whereas variance and standard deviation are then going from that average and then measuring out how far the data values extend from that point. Okay, so there's kind of a neat relationship between central tendency and variance and standard deviation. Central tendency is kind of where we start these measurements for variance and standard deviation, but instead of measuring where they're centered around, it measures how far spread out they are from the center. Okay, so when we talk about variance and standard deviation, here's the formulas for each of these. Variance is denoted as sigma squared, and that's lowercase sigma right here, that thing that looks like a circle with a little visor on it with a little hat. But that's sigma squared, and so what we have is x of 1 minus x of the bar over it squared plus x of 2 minus x of the bar. And just keeps going. And essentially what we're doing, the reason that dot 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 is there is essentially we're using up all of our data values. And then the difference here between variance and standard deviation is really just a matter of taking the square root of each side of the variance. So here, if I were to take the square root of each side, on this first side I'd be left with just sigma, and on the second side I'd be left with the square root of this whole thing. Okay, so really it's the same formula, except standard deviation is one step further, where we actually take the square root. And standard deviation is used far more often than variance is. And as we look at these formulas, that x with a bar over it thing that we see popping up all over the place, that's just our mean. Essentially, x with a bar over is like the average of x, saying the average of x equals the mean. Okay, so when we see these x with a bar over it, we're talking about the mean. So this is the mean, this is the mean, this is the mean. Okay, x sub n is each data value. So when we see something like x sub 1, we're saying, all right, the first data value. X sub 2 is the second data value, the third data value, the fourth data value, and so on and so forth. And that's why that dot 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 is there. We don't know how many data values we have until we get an example. We just use each of them. All right, and then n is the number of data values. So essentially what's happening here is I'm taking the first data value minus the mean, square it, plus the second data value minus the mean, square it, the next data value minus the mean and square it. And I do that with each of my data values. Then I add up all those squares that I just got, and then I divide by how many terms I have. So it's similar in nature to how we approach other things in terms of the mean. It's got a little bit of that thrown in there as we're dividing by how many we have. But it's just each data value minus the mean and square it, add them all together, divide by how many we have. Okay. For example, if I look at something like this, and this is an example that we've done previously, the first thing we always need to identify if we're going to do variance and standard deviation is the mean. So for this one, again, we've already done this previously, and when I identified the mean for this one before, it was 122. Okay, so that becomes really important, so I'm going to use that 122. So I'm going to find variance first, because it kind of just happens first. So I'm going to say sigma squared equals. So what I do is I take the first data value, which is 104, I subtract the mean, and I square it. And then I'm going to add, and now I take the next data value, the 117. I subtract the mean, and I square it. And then I do the same thing with the next one, and I just keep going until I've used up each and every one of these data values. And so after I have all those written, wow, that was a really ugly line that I just drew. Let me try that again. So after I have all these written, I just divide by how many data values I have, which in this scenario is 8. Okay? So I have 8 sets of these things in the numerator, and now it's really just a job for my calculator. Just be careful as you do this. The 104 minus the 122, that's going to be a 16, 17, 18, well, really a negative 18. The negative's not really important because once we square this thing, it's going to be positive anyway. So I square it and I get 324. So let me write that down. I'll just do this in a couple different steps. So I've got 324. Plus the next one, that gives me a difference of negative 5, and then I square that. That's a 25. The next one is the same as the first one. That's a 324. The next one, 136 minus the 122 is a 14. 14 squared is 196. The next one, the 189. This is was my outlier before when I looked at central tendency. So this one's a little bit out of the ordinary, but that's okay. When I subtract, it gives me a 67, and when I square that, it gives me 4,489. So again, I'm just working each of these out. The next one, 109 minus the negative 122 is a negative 13 squared, which is a 169. The next one, the 113, that's a 9, or negative 9 squared, which is 81. And then the last one, once again, we have that 324, because it's still the 104 minus the 122 squared. Again, it's all over, it's all divided by the 8. And now I just keep going, so I keep simplifying these things. So I'm going to add that numerator. Wow, that was a really ugly looking equal sign. So I add that numerator together, so I add all those up. And when I do that, it gives me 5,932 over the 8. And now I divide, and it gives me 741.5. Okay, so my variance this time, so variance is denoted this way. The variance is 741.5. And now from here, the standard deviation, I'm obviously not going to plug it all back into that formula. I'm just going to do the same formula and take the square root at the end. So really all I have to do is take the square root of the variance, and that gives me for sigma, for the variance, it gives me 27.23. Okay, and so what this kind of shows me, and as we do more examples of these and we look at different variances and standard deviations, you're going to find out that the more spread out that data is, the larger these values are. So something like a 27.23 for our standard deviation, when we're talking about something as small as bowling scores that can only range from 0 to 300, that's a pretty significant difference and a pretty significant jump, which means these are fairly spread out. And really the culprit of that is this guy right here. It's that outlier that we saw before. And so not only does that affect the mean of this, but it also affects the variance and the standard deviation as well. Okay, so again, variance and standard deviation, it's just a quick way to see how spread out this data is. If we have a standard deviation that's very low, it means all the data values are clustered pretty closely together. Okay, and we'll take this a step further as we start to look at normal distribution curves and how the standard deviation is plotted in respect to the mean as we start to do normal distribution. But there's variance and standard deviation. Okay.